Today's lesson, limits,
Taught by LaShawn Roberts.
Elisa Tillman. Mathematics, a limit is the value that a function or sequence approaches as the input or index approaches the same value.
For example, there are easy limits where you can simply substitute the answer into it. So we have limits x approaches 2. The equation is 3x plus 4. So what we do is we put in 2 for x. 3 times 2 equals 6 plus 4 equals 10. 10 is not your answer. However, sometimes it doesn't work. So what we do is we factor. What you don't want is 0 over 0, which is undefined. So for example here, x squared minus 9 can be factored into x plus 3 times x minus 3. These then cancel out. You're left with x plus 3. Now it's an easy limit once again. And you simply put 3 in for x. 3 plus 3 equals 6. That is not your answer. You can also make an XY chart to find your answer, if all else fails. So the limit as x approaches 5. You find a number that leads us to 5. You have 3, 4, 4.5, 4.9. You then plug that into the equation. And you get the number that's leading up to. For here, you can see it's decreasing and it's leading towards 0.6. So 0.6 is indeed your answer. Now, sometimes the limit does not exist. Okay, when there's a negative sign, yes, Alasia.
When does it not exist?
It doesn't exist when it's in the same proportion from the left and from the right. For example, when there's a negative sign on the outside of the number, it means it's approaching from the left. When it has a positive sign, it's approaching from the right. Now, for example, in this problem right here, f of x equals 1 plus 3 divided by x minus 2. This is a graph of it. Yes, Alicia?
So the minus sign and the plus sign does not mean that's the sign for the numbers?
No, it does not. It does not mean that at all. It tells you where you're approaching from. Negative is left, positive is right. Okay. Now, for example, in this problem right here, f of x equals 1 plus 3 divided by x minus 2. This is the graph for it, by the way. As x approaches 2 from the left, it goes towards negative infinity. From the right, however, it goes towards positive infinity. Therefore, when its x is approaching 2 with no symbol, it does not exist whatsoever. Yes, Alasia?
Why?
Because it must be the same coming from the left and from the right, which in this case it does not. How does it even apply to the real world?
Glad you asked that. In fact, a lot of you out there are probably wondering, how does this apply to the real life world?
I am.
I'm gonna tell you. Informally, a function plus assigns an output of f of x, which is, as you know, y. To every input x, the function has a limit L at an input p if f of x, y, is close to wherever x is close to p. In other words, f of x, y, becomes closer to p itself. Your speedometer in your car. The reader of your speedometer, e.g., let's say it was 85 kilometers an hour, is a limit in the real world. Your speed is continuously changing during or over time. And the only solid data that you could get is that it took you exactly 2 hours to drive 150 kilometers an hour from A to B. The figure of your speedometer gives you B2 equals triangle plus goes to OS to the equation negative S TO minus triangle T all over triangle T, where S times T denotes the distance traveled up to time T. Why? Real life limits limits are used anytime you have the same type of real-life application approach in a steady-state solution. You can also derive this kind of things in engineering. Another example, we could have a chemical reaction in a beaker start with two chemicals that from new compounds over time, the amount of a new compound is the limit of a function as the time goes to positive infinity. Thank you for listening. I'm Alicia Tillman.
And I'm LaShawn Roberts.